Okay, 8.3, we're going to look at the last property, power of a power, and review different problems that have several properties within them. Okay, in power of a power, we have a power raised to another power. Okay, so in this case, we have a cubed squared. Okay, now a cubed squared is technically a cubed times a cubed. All right, a cubed times a cubed. And we learned that when we're multiplying powers, we just add the power. All right, which is a to the sixth. Okay, but with the power of a power, we could shorten this up a little bit. A cubed to the second power is a to 3 times 2. We just multiply the two powers, which is a to the sixth. Right? So 4 to the sixth to the fifth is 4 to the sixth times 5. And that's 4 to the 30th. Now we're not going to calculate that because it's going to be an enormous number, so we'll just leave it as it is. All right, y to the negative 3 raised to the fourth is y to the negative 3 times 4, which is y to the negative 12. Now this is the negative exponent property, so we go 1 over y to the 12th. Put the term in the denominator and make the exponent positive. All right, let's look at a couple more. We have 3x to the fourth squared. Now, this deals with the product to a power. All right, so the 2 technically is going to both the 3, which is 3 to the 1 times 2, and to the x to the fourth times 2. All right, it's kind of like you're distributing the exponent to both terms within the product. All right, so we have 3 squared x to the 8th. All right, we could simplify 3 squared, that's 9. 3 times 3. So we have 9x to the 8th. All right, similar to here, 4 raised to the fourth power, x squared plus y to the fifth raised to the fourth power is x squared times 4, y to the fifth times 4. So that's x to the 8th, y to the 20th. All right, x to the third, y, z to the fourth, raised to the fifth power. So we have x to the third times 5, y to the first times 5, and z to the fourth times 5. All right, so you get x to the 15th, y to the 5th, z to the 20th. All right. Now what we're going to do is we're going to review all of the properties, all right, by looking at different examples and going over them together. Okay? If you feel like you can answer each problem on your own, pause the video, all right, and then watch it to see if you got your answer correct, and then move on to the next one. All right, so we have 2x squared times 2x cubed. Okay, so what we're going to do is we're multiplying, so we multiply 2 to the first, all right, 2 to the first and 2 to the first. They have the same base, all right, so we're just multiplying 2 to the first, so 2 to the 1 plus 1, all right. That's the same thing as just doing 2 times 2. All right, so anytime we have a numerical coefficient or a coefficient, we're going to just multiply them. So 2 times 2 and then we'll deal with the exponents separately. And at the end, we'll combine them later. All right, 2 times 2, and then we have x squared times x cubed. So we're multiplying, so we'll add the exponents. 2 times 2 is 4. X to the second times x to the third, or cubed, is x to the fifth. Next one, we're going to multiply the coefficients. 4 times 2. All right, and then we have like bases, y. So we got y to the negative 3, and we're multiplying, so we're going to add the exponents. Plus 2, so we have 8, and we have y to the negative 1. Okay, we can't have a negative exponent, so we use the negative exponent property. All right, y is raised to the negative 1, not 8, so 8 stays in the numerator, y goes to the denominator. All right, and we don't have to put y to the first because it's already given if there's a y. All right, next one, 2z to the fourth, 4z. All right, multiply the coefficients. 2 times 4. All right, and we're going to add our exponent, z to the fourth plus z to the first. So I have 8z to the fifth. And there's nothing else we could do, so we're done. Again, we can multiply the coefficients. 2 times 3. And then we have a squared times b. Okay, now they have different bases, so we can't do anything with them. So it's just 2 times 3, a squared times b. Number 5, we have 4c cubed d squared times 3c to the negative 4 d to the negative q. All right, so we're going to, again, multiply the coefficients. 4 times 3. All right, we have like bases with c's, so c to the 3 plus negative 4. And then we have like bases with the d's. Okay, d squared plus negative 3. So we have 12c to the negative 1, d to the negative 1. Now with negative exponents, again, we have to put them in either, if they're in the numerator, we put them to the denominator, and if they're in the denominator, we move them to the numerator and make the exponents positive. Here, they're all in the numerator, okay? So we have 12 stays up because it's not a negative exponent, and c and d move to the denominator. Okay, and remember, we have this like invisible 1 power here. Okay, we made it positive. Example 6, we have f squared to the 0 power. Now this is the power of a power property, so we go f squared times 0. We multiply the two powers. 2 times 0 is 0. Alright, and then we have the 0 exponent property. Anything raised to the 0 power is 1, even if it is an f. Example 7, 4g to the 0 power raised to the 4th power. So we have 4 to the 4th, 4 to the 1st times 4, okay, because we have a power to a power, and again, this invisible 1 that's there, okay, and then g to the 0 times 4. So we have 4 to the 4th and g to the 0. 0 times 4. Well, g to the 0 is just 1. And 4 to the fourth, if you multiply it out, is 16 times 16, 256. Alright, so we have 256 times 1, which is 256. Example 8, 3h to the fourth raised to the fourth, so we have 3 to the first times 4, h to the fourth times 4. Alright, 3 to the fourth, h to the 16th, 4 times 4. Alright, 3 to the fourth is 3 times 3 times 3 times 3, which is 81, h to the 16th. Example 9. We have 2k to the fourth to the negative 1. Alright, now there's two ways to do this. Since the whole thing is raised to the negative first power, we could just flip it. Because it's to the negative first. If you did it out, we would get 2 to the negative first, or 1 times negative 1, and k to the fourth times negative 1, which is 2 to the negative 1, k to the negative 4. Alright, we have to put those in the denominator and make the exponent positive. And since we put both of them to the denominator, what's left in the numerator is just 1. Same thing with number 10. The whole thing is raised to the negative first power. Okay, so let's do this one out. 2 to the 1 times negative 1, m to the 4 times negative 1, n to the negative 3 times negative 1. 2 to the negative 1, m to the negative 4, n to the positive 3, negative 3 times negative 1. Alright, our 2 and our m are negative, so they go to the denominator, and the exponent becomes positive. And then the n is positive, has a positive exponent, so that stays in the numerator. Number 11. Okay, again, we deal with the coefficients separately. Alright, so if we look at this problem, we have 2